Hello and welcome to section 9.3, which is called Classifying Polygons. So the word poly just means more than one. Okay, so like a triangle has more than one side, quadrilateral, and that sort of thing. So here's our little cheat sheet that I would make sure you have so that you can know how to classify all of the different polygons we'll be talking about. A polygon is a closed plane. So plane means it's just flat. It's flat on a piece of paper. It has no volume. It is just a flat figure whose sides meet only at their end points. Okay, so what that means is that we're not going to have like a polygon that looks something like this. That's not how we draw a rectangle. We have an end point, goes there. Meets at that end point, goes down, meets at that end point and that end point. Okay, it doesn't go on and have extra stuff. They meet only at their end points. So number of sides. A three-sided polygon is called a triangle. Just in case you haven't heard that word before, there it is, triangle. Four-sided is called a quadrilateral. Okay, we know squares, we know rectangles, but if we take a step back, our bigger picture is it's called a quadrilateral. Quad means four, so quadrilateral means four-sided figure. Pentagon is five. Penta means five. Hexagon means six, has six sides. A heptagon has seven sides. Octagon has eight sides. Think of a octopus, has eight tentacles. Octagon has eight sides. Nonagon is nine sides. Decagon has 10 sides, like a decade is 10 years. Decagon is 10 sides. An undecagon is 11. A dodecagon is a 12. Okay, and then after that it would be a 13agon, 14agon, and so on. Okay, so n just means any number. We'd put that number and then we call it a gon. Okay, n is our variable for any number. We'd plug whatever number of sides it is in. That's what we would do for an n-agon, which just means any number. Okay, so this one does have quite a bit of writing. So for triangles, there are two ways to classify. Let's label them here. This is 1, 2. Okay, so our first way is to classify by their angles. Okay, so if I have a triangle, and I know that all the angles are the same. Remember I told you that little half circle, that means that they are congruent with each other. If they all have one, that means every angle is congruent. That is called an equiangular, where all angles are congruent. Acute. An acute triangle means that all angles are less than 90 degrees, or acute. Remember, think of acute little triangles. Acute little angle. Okay? Then we have a right, where there's exactly one right triangle, one right side, sorry. Right means where it will show you it is right by doing that, and then it will just connect. Okay, then we have an obtuse, where one angle is obtuse. Obtuse means, no, I didn't put that in there, more than 90 degrees. So if it looks bigger than this, then it could be an obtuse angle. Or we classify them by sides, which is much more, it's much more common to do it this way, that we would classify them by our length. So we have an equilateral triangle where all sides are equal. We show that by putting one little hash on there. Then we have an isosceles triangle, which let's say it looks like this, where this side is congruent to this side and this side is different. Okay, so two sides are congruent. And then we have a scaling where all the sides are just different. Okay, so as you can see, they don't have any hashtags that are the same or little hash marks. Okay, so they are all different. So this would be scaling, isosceles, and equilateral. Okay, so that's how we classify these ones. Now let's practice. We have to classify both their angles and by their sides. So our first one's going to look like this. And again, we have to go by the markings and not necessarily by how I draw them, okay? Because can I draw them exactly the way they need to be? Not on an iPad, and I probably couldn't even do it on a piece of paper, okay? So what this one says is this one has 2 lines, this one has 3 lines, and it has 1 right angle. Okay, so first let's classify the angle. And the angle would be, let's see, exactly 1 right angle. So this is going to be a right. And then we have to classify it by side length. All the sides are different. No congruent sides, so this would be scaling. So we would call it a right scaling triangle. That would be what our first one would be called, a right scaling triangle. Number 2 has a picture like this. And it shows this and this. Okay, so our angle, what is our angle? Is exactly 1 obtuse angle. Hey, you guys, this one's like huge. Okay, so I'm going to call it obtuse. And this one I'm going to ask, what is my side lengths? Has 2 congruent sides, so I know it's an isosceles. So this one would be an obtuse. Isosce. Isosceles triangle. Okay, then we have to do one more here. I'm hoping I can fit it in. Number 3 looks like this. It shows, okay, we'll go like this too. So all sides are, all angles are congruent, so we know it is an equiangular. I'm going to just scooch this over here a little bit. Okay, and what about our side? Well, all of our sides are congruent, so I know it is an equilateral as well. So to classify this one, I would call it an equiangular, equilateral triangle. And like I said before, when you're doing this, you're really going to call this one an isosceles. You're going to call this one an equilateral triangle. And this one will be a scaling triangle. That's typically how we classify triangles, is by their sides, not usually by their angles. But it's good to know how to classify them using angles as well. Okay, let's go to the next slide here. Quadrilaterals. Quad, we have that quad again. We know it's 4. So we have a trapezoid, which again looks like this. We found the area of these, you guys, so we should be good on them. It has exactly 1 pair of parallel sides. Then we have a parallelogram that looks something like this. Like a triangle, but two sides are slanted. Or sorry, not a triangle, a rectangle. But two sides are slanted. Then both pairs of opposite sides are parallel. So these two sides are parallel, as are these two sides up on the top and the bottom. We have a rectangle. It's an equiangular parallelogram. On a rectangle, all angles are 90 degrees. Okay, that's why it's called equiangular. They are all equal to each other. Then we have a square that is equiangular because they're all right angles, and all the sides are the same. Equiangular, equilateral, parallelogram. Example. Okay, now these ones you have to kind of think a little bit. It says list the quadrilaterals that have 4 right angles. Okay, maybe not. Well, we already know the 2 that have 4 right angles. Rectangle and square. Okay, those are the only 2 quadrilaterals that have 4 right angles. And I forgot to add one more in here. We do also have what is called a rhombus, and that's kind of what we typically picture as a diamond. Okay, because a rhombus has it's equal sides, equilateral, but they don't have to be right angles. Okay, so I mean a rhombus could be, yeah, usually like that. Like a diamond is what a rhombus would be. Okay. Then let's go back to list the quadrilaterals that have both pairs of opposite sides that are parallel. So both opposite sides have to be parallel. We would have parallelogram, both sides are opposite, rectangle, both sides are parallel, sorry. A square. And we know a rhombus is called a parallelogram, so we know a rhombus is also the same. Also has both pairs of opposite sides. Okay. I think that's all we've got for those. Let's go to the next slide. Naming quadrilaterals. So what we're going to do here we have a little example. And our example is this. Okay, we have a point here, which is point B. We have a point here, which is point C. Point here, which is D. And we'll come back to our little friend, the A. So how I would name it, I would name it capital A, capital B, C, or D. Or I would name it D, C, B, A. I would not do A, C, B, D. Okay, so I want to pick a point. Like, I even could pick C. I could pick C, D, A, B. But the problem is if I do A, C, B, D, I'm going A, C, B, D. I'm making a cross in the middle, and that's what I don't want. So when I name it, I just have to pick a point. I could pick D. I could go D, A, B, C. Okay, but I just have to make sure I'm going around the outside and pick a way to go around. Okay. Then we have a thing called a regular polygon, which is equilateral, equal sides, equiangular, equal angles. Okay, so these are going to be things like your hexagon, your heptagon, your whatever that we've found the area for. Then let's talk perimeter is the distance around the figure. So this is if I wanted to put up a fence around a trapezoidal area in my yard. How much fencing would I need? Okay, so this is not what's going on the inside like area. This is just finding the distance around the outside. So let's say, example, write a formula for the perimeter of a regular hexagon. Okay, so a regular hexagon is going to look something like this. And now I know we did this last year, where what we did to find the area, the perimeter, not even the area. Okay, so let's say one of our sides is S. I would have how many S's? So perimeter of a hexagon would equal 6S. And S is just whatever the length of that side is. We need to add 6 of them, or we could just multiply it by 6 to make our life a little bit easier. A regular octagon. Now, an octagon is like a stop sign. Okay, that's not so much like a stop sign. Just give me a break, all right? Okay, so I have side, 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 side. So I have 8 sides, so the perimeter for an octagon, I would just take 8 times the side. So, I mean, it's just if the side is 6, then I would plug in 6. 8 times 6 is 48. So the perimeter would be 48 inches, feet, whatever it would need to be. Okay, so we just have to take the number of sides times how long one side is, and that will give us the perimeter of our polygon. Okay, so let's try this one. Write a formula and find the perimeter of a regular decagon with a side length of 7 centimeters. So our formula, just like we just did on the last slide, I better not write and talk. Our formula would be, write a formula, okay, there's deca, I'm thinking decade, so I know it's 10S equals perimeter of a decagon. Okay, so I need to take 10 times the side length of 7 centimeters. That's going to equal my perimeter. Okay, 10 times 7 is 70. Get my unit down, centimeters. That is going to be the perimeter of my decagon. Okay, so hopefully you guys, this will be a little bit easier. I feel like this chapter, yes, it's a lot of writing in your notes, but I think it's a lot easier doing the homework. I didn't assign too many problems. I just kind of want to get you introduced to this stuff because you will definitely use it again when you go and take geometry in 9th grade, maybe, something like that. So this hopefully is going very well for you guys. Please come in and see me if you have any questions. Otherwise, thank you for watching.